Greetings from Orbit NITT. This is our pitch video for our first ever entry at the LASC 2026. Our mission name is Magnus Quilla. Let's dive into further details. This is our team structure. It consists of 6 people. Coming to the mission overview, our rocket from the launch aims at a 3 kilometer apogee, followed by a dual deployment recovery system where a drogue will be deployed at the apogee and a main parachute followed, which ensures safe touchdown and recovery. You can look at the rocket on the right image.
Our project focuses on building a reliable and efficient rocket system with three main components: the flight computer, telemetry system, and recovery system. The flight computer is powered by TNC 4.1 microcontroller, which allows fast real-time processing during flight. It integrates 9 onboard sensors to monitor important parameters such as altitude, acceleration, orientation, and environmental conditions. The system is also modular, making it easy to upgrade for future missions and payloads. Next, our telemetry system uses LoRa-based wireless communication to send live flight data from the rocket to the ground station. It continuously transmits information such as altitude, mission time, acceleration, and GPS location. The system operates at 868 MHz and supports communication over distances of up to 5 kilometers with full duplex capability. Finally, the recovery system ensures safe retrieval of the rocket after landing. A dedicated algorithm processes parametric and accelerometer data to trigger recovery events and control the air braking system. An onboard GPS module provides real-time tracking, while a buzzer and high-visibility LED beacon help locate the rocket quickly after landing. Through this project, we aim to develop a safe, scalable, and high-performance rocket platform for future aerospace missions. Thank you.
Coming to the airframe of Magnus Quilla, there are three main parts to go over. The nose cone is a 65 cm long tangent ogive with a 13 cm base diameter made of fiberglass. Open form simulations indicate the nose cone has a viscous drag coefficient of 0.0573. The fuselage comprises two body tubes, both having an outer diameter of 13 cm and is made of fiberglass. The upper body tube houses the recovery and payload systems, and the lower houses the solid rocket motor. They are they are joined using couplers of 6 cm length. The four fins are trapezoidal, 3 mm in thickness, ensuring the rocket's stability. Fin flutter is in progress, with meshing completed for the CFD and modal analysis.
Coming to the propulsion part, we are using a solid rocket motor which uses a cherry limit as the propellant of 5 grains and 3.5 kg weight. It uses Bates geometry with 75 mm outer diameter and 134.4 mm length. We are using this motor with a chamber pressure of a stable 500 psi and a burn time of roughly 3.57 seconds. It produces a net impulse of 7630.297 Newton second, which is plenty enough to propel the rocket to the aimed 3 kilometer apogee. On the bottom right, you can see the static pressure contour of the flow simulation of the nozzle. This is our testing video for the motor with KNSD. Coming to our recovery system, we have made a dedicated algorithm which processes the barometric and accelerometric data, which triggers recovery events and controls the air braking system. Additionally, an onboard GPS module which transmits real-time coordinates to track the rocket's precise location, while also a buzzer and LED high visibility beacon which activates upon landing to facilitate rapid visual and auditory location for final recovery has also been incubated. The recovery is a dual deployment event where a drogue parachute will be deployed at the apogee, followed by a main parachute which deploys at around 10 to 15% of the apogee distance above ground level. The deployment will be performed through black powder ejection charges. A toroidal parachute will be used for high performance and better packing volume. The parachute will be made of ripstop nylon having a spill hole with 10% radius of the parachute canopy. This is a schematic for our recovery system. Thank you.